I have invited Carlos, who is a research scientist at Intel. Carlos will give you the technical perspective of how to basically start in variable space. So we heard that from Steve, that what are the opportunities and what's the landscape. Now Carlos will actually walk you through the how to build a rapid prototyping using Galileo, Intel Galileo, and Edison. So the same thing, same class we're teaching tomorrow at Stanford, me and Carlos. So you will get the preview of this, what we're teaching tomorrow. But Carlos is going to show you, you are an engineer, you're technical, you want to build something, how to build the prototype so quickly without burning a lot of cash. So I'll introduce you with Carlos. Carlos?
How's it going? Can you hear me? Good? So thank you very much for that intro, and good morning, everybody. Thanks, SIPA, for inviting me. As he said, I'm actually a research scientist. I work for Intel Labs, specifically for a lab called User Experience Research. And I would like to get a raise of hands here just to understand my audience. How many of you are technical? Who considers themselves technical? Okay, good. Anybody considers themselves a designer? Good, we have a couple, so these guys are going to understand my talk today. For those of you who are really, really technical, I want to tell you, I'm going to start with a little story of how a robotics engineer myself moved from a very technical field to design. And I actually discovered a completely different world, and how that actually brought in with a really big group of people at Intel, and we are actually pushing user experience and rapid prototyping within a hardware company, which is a really interesting, it's a really interesting shift for a company that has been building silicon around the world and for decades, right? By training, I'm a robotics engineer. I started my career in manufacturing, developing robotic prototypes for the fabs. And one day, a group of 5 engineers in Arizona, we designed a graphical user interface for robotic systems in China. Guess what? We started getting phone calls at 3 o'clock in the morning. And we're like, what's up with these guys? I mean, we know we developed these graphical user interface and these robotic systems perfectly here in the United States for 1,000 Chinese engineers, right? So first call, 3 o'clock in the morning, oh, these guys. I mean, so we were debugging, fixing the whole thing. And then we realized that there was something wrong with this whole situation. And the problem really wasn't the design itself. It was that we had not taken into consideration the user. And even though we were designing robotic systems, hardcore technology, we put the user at the end, right? So we had to send an entire team to China to literally stand behind our robotics engineers and the people in the fabs to observe and understand how they were using their robotic systems. Well, guess what? When we had trained some of the engineers here in the United States how to use the machine, they have these, they have certain, well, in the United States we have certain reading patterns, right? But in China, specifically the target we're looking at, they have completely different reading patterns. So these guys were actually hitting the buttons in the completely wrong order, and so we had to go back and reiterate and rechange the whole thing. So rapid prototyping and user experience and putting ourselves in the shoes of our users was very critical. And that's what actually pushed me to move into research in specifically user experience, and I decided to move to Intel Labs. I'm currently part of a group that's called, well, it's basically user experience, but we have different vectors. One is technology, the other one is design, the third one is basically business, and the whole organization is being led by an ethnographer. The idea behind this is combining design, technology, and of course, ethnography. Now, all of you now moving a little bit more towards the maker space and rapid prototyping and how Intel, Galileo, and Edison and these technologies are popping up. Within this group, we identified that there are a lot of people. How many of you guys like to tinker during the weekends or after work? How many of you actually sit down and build things, either for yourselves or your kids? Right? So there is one of them, for example. When we met, he was like, oh, I have my kid, he has this one idea, we want a rapid prototype, we want to build it. And I'm like, yes, you can use Arduinos, you can use your LilyPads, and actually Intel now is getting into that rapid prototyping. And we're going to get into, how many of you have heard of Nixie, the product that, the Make It Wearable product? Okay, we're going to get a little bit into that and how we used Intel technologies to rapid prototype that. But anyway, so the maker community, what's happening now, it's manufacturing is changing. right? How people build products. It's changing dramatically, the tools. The whole community, the maker community started here. There's a maker fair takes place in San Mateo once a year, and this October we were in Rome. Last year we had 35,000 people attend Maker Faire, all sorts of inventors, people just building all sorts of gadgets coming from robots, connected homes. You cannot imagine all sorts of wearable clothing. They were adding all sorts of sensors and things like that. It started last year, we had 35,000. This year we had 90,000 just in Rome. Here in the United States, the number is increasing every single day, and we have maker fairs all over the country. And what is this maker movement, right? People just like you guys, they like to spend time building products, building their ideas, just building stuff. And the pattern that we're seeing is in the 80s, people were building hardware, right? Then, of course, the software around the hardware, then we moved into the internet. But now we're going back to hardware again. And the pieces of hardware that people are building are really tiny embedded systems, right? Now, Intel identified this, and there's another community, the Arduino community. How many of you have heard of the Arduino community? Gosh, I really wish we would see more hands up here, right? It's because it's a really easy to program embedded system. If you go look and do some research, the people who developed the Arduino system were a bunch of designers, artists, who wanted to develop products and interactive systems really, really quick. But they had no tools, because when they went out there to the field and try to get the right embedded systems tools to work with sensors, actuators, and these type of technologies so they can test things really quickly, they found themselves with these really huge processors, right, back in the days, with these huge programmer machines where you had to put in the slot, kind of like, start jamming things in there. There were no really easy tools to program the devices. So they decided to start everything from scratch, and they developed their own platforms. They open sourced everything. So moving towards open software to open hardware. So all the schematics, the BOM, absolutely everything is on the web for you to actually download, create your product, test the market, see if there's a market fit, and immediately start ramping up in production. A lot of these people are developing, at home, and then through like Seed, Seed is SEED, is a company in China, which is basically dedicated and focused to the maker community. They take those ideas, they work with you, and they have small runs of production for you before you move to a Foxconn or something along those lines. So enabling designers, enabling people who want to rapid test, and that's what's happening now in the maker community, and this community is growing tremendously. Intel saw that opportunity, and we immediately jumped into it. We designed these two platforms, Galileo and Edison, which I'll get into later, but basically, this is our target. Now, I want to show you a little bit as to what I personally do in my lab and why we do what we do. The board that you see up here on the left is a Galileo board. And this is basically an equivalent of an Arduino board, except that it has an Intel chip on it. We partner up with the Arduino company, and we decided to develop a very flexible, basically evaluation board. Now, one of the challenges that we had in my team was, for those of you who like to program and develop on hardware, is basically get thing up and running and run the hello world. Anybody has an idea of what the hello world equivalent in the hardware world is? Awesome. Yes, perfect. We have 2 or 3. Good. I really would love if everybody knew that, because hardware is going to be the next big thing. So people are going to start developing hardware in high schools, in colleges, and the next big thing is going to come from literally a garage. Right? We know the story, right? We already know it. The tools are being built. So if there's something I would love you guys to get out of this talk, is to go and do some more research about these technologies, right? And next time, hopefully, everybody knows what a hello world in the hardware world means, and you can actually do it. So going back to this, yes, Intel, we developed the platform.
What was the answer?
Say that again?
The hello world in...
Oh, sorry. So the hello world in the hardware world is a LED blinking, right? So you get your LED to blink, and you're like, yes, it works, right? That's basically what it is. And now it's being considered sort of like a standard, that LED number 13, because in most of these boards, there is an LED attached to the pin number 13. So LED number 13 blinks, boom, you know it's working. Cool, sorry about that. So Intel, of course, we're a giant, right? So we go in there, we get our Galileos out the door, and guess what? User experience, of course, we jump in and we try to understand our users, and basically the same. My team and I, we did exactly the same thing we did with my robotic systems back in the days. We're observing our users, get through the whole flow to see the, to get the LED number 13 to blink. How much time do you guys think it took? Anybody, give it a shot.
2 days.
How much? 2 days. A little bit exaggerated, but good. It's a good guess. Anybody else?
Couple of hours.
Couple of hours, say 2 hours.
5 minutes.
5 minutes.
45 minutes.
45 minutes. Well, she knows. So, yeah, 45 minutes actually. 45 minutes. So imagine buying an embedded system, right? You have this awesome idea. You buy your device, you open the box, you turn it on, you start, and it takes you 45 minutes for an LED to blink. How frustrating is that, right? So we went with our team and we're like, okay guys, no, we need to fix this. We hired some interaction designers, some visual designers, and people who actually are empathetic with the user. And we said, okay, put yourself in their shoes, go through this whole thing, come up with a solution. And these are the different steps and iterations that we had to go through before we nailed a solution that we really think worked. What's interesting about this is the methodology that we used. So we used what we call in design, it's basically a lean type of user-centric design approach. You come up with an idea and you use the simplest elements that you can to materialize something, put it in front of people, get their feedback. Of course, you're never going to ask them if they like it or not, obviously not. You observe, see if they actually can or cannot do things, and then iterate. So as an example up here, that was really awesome because my visual designer said, I've done this before, this is fantastic. You know what we're going to do? We're going to package the Galileo, put it in the center of the box, and we're going to have 4 flaps. 1, they're going to read it, and they're going to say, oh, look, step 1, 2, 3. 2, open the next flap, and you're going to go through all the instructions, and you're going to start connecting things. 3, we're going to do X, Y, and Z, and then finally 4, and then you're going to have access to your device, and then you're going to have fun, and you're going to be able to program it in 2 minutes. What do you guys think happened? Exactly, right? They gave it to the users, and the users went boom, 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 grab the box, and now, how do I get this thing to blink? And we're like, and everybody's like, we spend like 4 days getting these boxes really pretty, and all the design, and all the flow, and all the communication, blah, blah, blah. Nobody read it, right? And this is a joke that I make in some of these talks, like, how many of you guys actually read the instructions? Right? Because if you're buying a piece of a gadget, you want to get to the gadget as soon as you can, right? That's why you bought the gadget. You didn't buy it for the box, right? So after seeing that, we're like, man, this is not going to work. So bam, we jumped into the next. We went through a couple of iterations, and we came up with this idea here, which basically is a little box with 2 flaps. So now you open it, and you see on one side sensors, and the other side actuators. You have the device, which by the way is the reason why you bought this, and you have everything there, right? Now, the idea of having sensors and actuators obviously is to allow people to start connecting sensors on one side, actuators on the other side, and start seeing things move and blink and things like that. Well, take a look at this. These guys created these little sensor modules that are actually attached to the flaps with Velcro, right? So and you have some little cables here on the side, so you can actually grab them and start connecting, turning on things, and just play with things. A lot of people, as soon as they opened, and they were excited about this whole the box and the components, they grabbed a cable, and immediately they try to connect to an LED. So they're trying to connect the LED module with from a side, and as soon as the Velcro started making that sound right, people will stop. They didn't want to break it, right? It's their new baby. Why would you want, as soon as you hear something weird, you don't want to touch it, right? And if it starts making this noise, you stop. And we were observing our users, and people, and they would go like, and we were like, what, tell me, I mean, why aren't you, taking the thing off? Like, I don't want to break it. We're like, no, you're not breaking. It's meant to do that. And they're like, but it sounds weird. It sounds like I'm breaking it. I'm like, So of course, nobody got the LED to blink in less than 45 minutes. We're like, oh, this sucks. So we had to go back again. And we took all the modules out for them. And eventually we came up with this solution, which is literally a little box with transparent doors. All the modules are already sitting there. And on top of it, we have an example of a button and an LED. So what do? You open the box, you see the LED there, you see all the modules, and boom, you hit the button, and bam, the LED starts blinking, right? So we went from 45 minutes basically to 2 minutes, right? Now, what's interesting about this is it's not necessarily the solution, it's the methodology that we used. Look at what materials are we using, right? A lot of people, when they go to our lab and see what we're doing, they're like, we're a hardware company. Why are you working with cardboard? And the first answer that comes from our mouth is like, it's cheap. It's fast. Why do you want us to start, to spend hundreds of thousands of dollars trying to develop a product or a prototype if we can just go ahead and use cardboard, paper, foam, right? In wearable devices, that's exactly where we're headed. I mean, why do you want to go and start, building, all these really complex devices or talking to manufacturing when you haven't even tested a small, when you can actually test your idea, say a bracelet or any type of embedded device with, 3D printed type of technologies or even cardboard, right? So initially it was kind of a hard sell within a hardware company, hardware company, right? When people come in and see our lab, they're like, what are you guys doing? But as soon as they start observing how our users can react to certain type of technologies, boom, they get it. So I guess that's the main point here. It's not about just the materials, it's how we use the materials and the methodology that we're using. Now, so unfortunately I cannot, my legal team, when they saw the picture that I put here, they said no. So I wasn't able to show you the real picture, but this is just a placeholder for me to remember. How many of you have seen the first Kodak camera, the first prototype for a Kodak camera? Perfect, a couple, okay, 4, 3, 5, got it. So there's this guy, and I forget his name, but he used to work in Kodak, and the way he convinced his management to actually move forward with the digital camera in Kodak was basically with a prototype, right? Now, what did the actual prototype look like? It looked like a big camera that was like something like this big, right? With a bunch of different boards. It had one of those, old cassettes, those little thingies. I don't even know what they call them. Cassette, that's what we call it in Spanish. But anyway, that's where you actually store the image, and it was on the side, right? And using these very clunky, very huge prototype, he managed to convince his team and upper management to, go forward with his idea. But it was all about rapid prototyping. He rapid prototyped his concept. He was able to communicate with, not with slides, not with, just a conversation, but with an actual prototype to show the value. And he, as an entrepreneur, was able to convince his upper management of the value of this technology, right? So that's where we're moving toward, that's exactly where we're moving with all these rapid prototyping technologies, because as an entrepreneur or an entrepreneur, you can definitely use these technologies to convince your VCs, to convince your people, to manage to get people on board and so on and so forth. And these are tools that are open hardware and open software, so very easy and cheap and accessible. So, prototyping. And we did talk about this. This is how we do things in my lab. We just use crafting materials. Come up with an idea, craft it in a couple of minutes, put things together where what's inside is, unfortunately, in this case, it's an Arduino, not an Edison or anything like that. But moving forward, we are using Edisons. So just using crafting materials to convey a message. 3D printers. Yes, 3D printers are not ready for mass production. That's true. However, for those of you who saw who are familiar with Nixie, the Maker Wearable, the challenge that we were involved with, the first prototype of this flying device, we actually built it with MakerBot, right? Yes, it was hard. Yes, it took 10 hours every time we run it and every time we wanted to print something. Nevertheless, we got it to fly, right? And it was extremely cheap. Right? Maybe 10 hours from a time point of view wasn't that cheap, but we managed to get it to fly. And 3D printers, yes, they aren't ready for mass production yet. They're perfect tools for rapid prototyping. And they're getting better and better. Electronics, craft materials, we kind of touched on this, and Intel prototyping platforms. So how many of you have heard of Galileo? Okay, cool, 5, 6. So again, what is this? This is basically a, for those of you who don't know what the Arduino, these guys did, again, these rapid prototyping techniques, it was invented in Italy. But what happens, what's more interesting about these boards is on here and up there, they have a little set of pins which allows you to plug in all sorts of daughter cards. Those daughter cards, so the Arduino community created an entire ecosystem of daughter cards and companies that actually are developing sensors, Wi-Fi cards, and all sorts of things that you cannot imagine. I mean, it's great. I mean, for all, compatibility with all sorts of sensors, actuators, all sorts of protocols, Wi-Fi shields, Bluetooth. It's, they have an entire ecosystem. So Galileo is basically the answer to Arduino. What we did is created a board with an Intel chip to marry the ecosystem with the high performance of Intel chips. And this specific board has a Quark chip. Now, this guy runs at 400 megahertz. The system, of course, has Ethernet. It has access to a 32 gigabyte SD card. It has serial. It has two USB ports. And you can program it using the Arduino IDE, which is a C++ version of the language. And it's you have compatibility with all OSs and all that good stuff. Now, this is more a wearable focused type of conference, so I'm pretty sure you guys are going to be more interested about Edison than Galileo. Yeah, I cannot imagine you guys creating a wearable with something like this. The board basically is like this size, right? I guess you could, and in fact, at the beginning, we actually did create some wearable type of prototypes, and we were carrying the board like everywhere, right? And you should have seen us. That was ridiculous, but we managed to get those prototypes to work. And now Edison is it's what's next. We released it a couple of months ago. The size of the device, it runs on a 5 megahertz clock. It's a dual core. It's basically an Atom SoC. It has a microcontroller embedded. It has Bluetooth and it has Wi-Fi, everything in the same board. And it has 1 gigabyte of flash and 4 gigs of, 1 gig of RAM and 4 gigs of flash. So it runs on Linux. And again, I would encourage you guys to go to makeitwearable.com. And no, it's makeit.intel, or just look for Make It Wearable. And what we have is the 10 finalists for the competition, where 10, let me back up here really quick. A couple of months at CES, Intel launched the Make It Wearable Challenge, and we received all sorts of applications from tons of entrepreneurs around the world. We managed to select 10, and the 10 finalists pitched their ideas in front of Best Buy CEO, VK, Intel CEO, and a couple of other renowned judges. And out of the 10, we chose a couple. But what's interesting about that is that all the prototypes of these wearable products were actually developed with Edison. So we had really interesting products, including a manufacturing glove that basically tracks the motion of the manufacturing employees and how to basically optimize the flow. And that was one of the winners. The other one was a robotic 3D printed limb for kids and people who've lost their arms. Really, really interesting. They're going to open source the software and all the product. But what's interesting about this is that they used Intel Edison to rapid prototype these concepts. They managed to come up with their product in less than 4 weeks. And using rapid prototyping technologies, they put it out there, tested the market, and guess what? A lot of them actually are getting orders now. Right? They managed to iterate their hardware, their software, their enclosures, their algorithms really, really, really quick. And they even, since the computer language is so flexible, they even managed to get people all over the world to contribute with the project with no problem at all. One more thing that I'm forgetting here, one of the specs is it has 40 pins, 40 I/O. Everything is interfaced through the little connector here on the left. And it has PWMs it's analog and digital. This is one example of a product, one prototype. This is a jacket which literally does biometrics. It has all sorts of sensors, and it gathers biometrics from patients and whoever is using them. We know this, one of my colleagues here just talked about this, about Intel Capital, but there's a lot of interest in wearables, of course, for Intel. And I'm just gonna leave it there for now. Yeah, well, for those of you who may not recognize these two guys, these are the Wright brothers, right? And what's interesting about these guys is we were having a conversation with SparkFun. SparkFun is one of those companies that develops daughter cards and little components for the Arduino community. And we were sitting in a room, and one of the guys says, well, the reality is that I would never fly on a plane that was designed or built by a maker, right? And then I thought about it, I'm like, yeah, you're right. The thing is that if you want to change the world, you've got to do what these guys did, which is you have to be a maker, right? Definitely these guys failed tons of times, right, before they actually got the thing to fly. Once they got it to fly, once they got their prototype to fly, they hired the engineers. But these guys were making, they were failing, right? And that's exactly the type of community that my team and the rapid prototyping platforms that we're working with are aiming for, right? People who are willing to jump in and break things, learn on the way, go fast, and basically change the world with their inventions. And here, this is basically our lemma within the group is just go ahead and basically start making. So that's basically what I had to share with you guys, and I will love to answer some questions, if any. Go ahead. Sorry, give me a sec. Do we have a microphone? Thanks.
Thank you. Thank you, that is a good one. I'm curious about one picture that you showed at the end, a jacket, Intel jacket with sensors. I'm curious to know where are the sensors and what are they trying to accomplish?
To be honest with you, I wasn't part of this project, so I really can't tell you all the details. I know that it took, it was basically, it had, the basics, heart rate, humidity, temperature, and just basic type of stuff. I'm not sure if this is going to become a product, but for sure it was a prototype they were testing, rapidly testing to see what actually makes sense or what doesn't make sense for people. And of course they were using the platforms I mentioned, which allow them to rapidly change things if they need it, which is the value of these rapid prototyping technologies. And sorry, the gentleman back there had a question.
Thank you for such an awesome talk. I just wanted to know if someone wants to start with the Edison.
Can you speak a little louder?
Oh, if someone wants to start playing around with the Edison that you just showed, what kind of technology that person will be learning? Like, what kind of language, like in C++, like you mentioned, or how should we start? Like, what are the first 5 steps a person should be taking?
That's a great question. So as of now, Intel basically supports 2 IDEs. One is the Arduino IDE, which is basically, again, it's a version of C++. And we also have Eclipse, where we basically are supporting Eclipse. There are other IDEs we are working with. We're still working on, I think it's called XDK, and which is mostly, well, you can do JavaScript and a bunch of other things, apps as well. And there's a 4th one that I don't remember, but mainly would be the Arduino IDE. A lot of the 10 finalists for the Make It Wearable Challenge, they all developed their code with the Arduino IDE. Again, it's not the best compiler in the world, but the idea is not to mass produce anything with these type of technologies, is to rapidly test your idea. Before you even get VC funding, before you even hire your people, focus on getting it right, or as right as you can, rapidly, failing rapidly before you jump to the next level. So for rapid prototyping, it's perfect, and so far we've seen a lot of value moving quick rather than spending time trying to get the more resources. So, yep.
Hi.
What's the difference between Raspberry Pi and Intel Galileo? Are they similar?
Of course, there are many, many differences. Well, the first one is, and most important one, is Raspberry Pi is basically an entire computer, right? In the sense that you have all the ports, you have to plug in your, it has in memory, you have to plug in all, the keyboard, the mouse, it has video out, so you literally have a computer in this size, right? The motherboard is really tiny, and you have to program, compile, and everything runs, right? Now, remember that Intel is moving into the wearable space, right? So yeah, the Galileo board is our first board. It basically looks like this, right? Edison is basically this. I can't tell you where we're headed, but I think you know where we're headed, right? If you start here, move to there, you can imagine what the next steps are. Now, if we go smaller, can we plug in a keyboard? Do we really need a video out? Are we going to plug in a mouse, right? So we are moving towards developing really, really tiny embedded systems, and that's basically where we think that's actually the market we're aiming for, right? So size is one of the biggest advantages, and of course the computation power that it has on board.
Any more questions?
Hey, yeah, I have a question. So, as I understand, Galileo is for home automation. So, is Edison actually replacing that, or is Edison more focused towards wearables?
Sorry, say that again?
So, as I understand, Galileo is, it was focused more towards home automation kind of projects, and then Edison is the smaller version, which is more focused on wearables. So, is Edison actually replacing Galileo?
That's a great question. Now, I guess it depends where you're coming from and what you want to do with these platforms, but Galileo wasn't really dedicated or focused for home automation. It was basically for rapid prototyping, right? So if you have an idea, you can use Galileo. Let's put it this way, it was always targeted more towards the, students, hobbyists, people who want to tinker, and that's basically what the Galileo board was for. Now, Edison it's basically the pro version of that. And I mean, one of the key feedback that we got from our users, of course, if they want to use it for wearables, is they need it to be small and more powerful. So if you think about it, the Galileo boards are more for hobbyists, teachers and students, whereas Edison is more the pro version for people who actually want to develop products on the platform.
So what you're saying is Edison can actually go into a production product directly, whereas you would tinker around with a Galileo, and then you would have to build your own PCBs and then finally make your product. Is that what it is?
Sorry, I can't hear well.
Oh, so I was asking, because Edison is kind of tiny and it is made for wearables,
Right.
Is it something that you can directly take into production and then directly insert into your product? Because Galileo is something that you tinker around and then you build your prototype and then you go back and take things from, because this hardware is open source. You take the reference design, take the parts that you need and build your product. Now, how about Edison? Can you just take it and then put it in your wearable, or is it still for tinkering and working around things?
That's a great question. And so the answer is, of course, yes and no. Yes, because literally you'll get this board, and everything around the board is, all the boards that we've designed and the software is open hardware and open software, right? So you have an idea, you can use those references and build your own platform. Now, as of now, you would have to buy the module, plug in the module on your device, and you're up and running. That's the current model. Now, that's changing because we know that eventually you want to have your own board and get into mass production and ramp up. But as of now, this is the model that we currently have.
Yeah.
So yeah.
So are there alternatives to Edison as well as of today?
Say that again?
Are there alternatives to Edison? Who are the competitors to Edison?
In this specific space with this specific platform, not that I know of. I mean, with this form factor, having a module that's easy to program, has a Bluetooth, Wi-Fi, 500 megahertz type of technology. I mean, 2 cores, an MCU in it. We haven't seen anything like this. So, like, people get really excited about how they can leverage OpenCV, computer vision, how they can run machine learning type of algorithms. It's high performance. So, there's a lot of stuff that a lot of companies are starting to look at how to leverage the form factor and the processing power of the device.
In the interest of time, please limit one question per person. If you have any follow-up question, please, feel free to reach out to him after the session. Go ahead, please.
So, the gentleman over here.
Power source for Edison, do you provide the power source with the board, or you gotta make arrangements on your own? Does a battery come with?
Oh, I see what you're saying. Okay, so the way it works is, yes, you do have to plug in the Edison into an extension board to power it and have access to the pins. So the answer is no, it doesn't come with a battery. But SparkFun and a couple of other third parties are actually developing all the modules, so you can just buy them and plug them in. They're actually, SparkFun has a battery pack, so literally it's the same form factor. You plug it in, you can plug in a power source like an external power supply or a battery, a lithium battery. So yep. And there are tons more. Like the coolest one that I've seen so far is basically very similar to the one that we use for Nixie, which has IMUs, all sorts of sensors, altimeters, and all sort of really nifty sensors, of course, power as well. So you plug it in, it basically looks like two layers, one stack on top of the other, and then you have everything on one module. So it's really fun.
Thanks for the informative talk. I wanted to see if you can give us some insights into the ongoing research at Intel, like the kind of patents that you have filed in the wearables area and any other research insights?
I will, just to answer on behalf of him, don't ask any confidential information for any company. That's, I don't think that he would be able to release that kind of information.
The patent application is not...
the answer is, I'm sorry. That's IP, so yes, we're doing a lot of stuff. Yes, we're doing a lot of research, but we're going to keep it for ourselves.
Suffice to say that Intel is filing a lot of patents. Mm-hmm. I can see, right? Did I answer the question for you, Carlos?
We are filing a lot of patents.
That's a fair answer, right?
Yep.
So, question for you. We spent quite a bit of this morning talking about the data and the experience ultimately that makes a product successful or fail. So once you get the lights blinking, what's the next step where Intel is helping the developers to build that overall experience? Are you guys helping anything on the back-end side, building the app?
Sorry, could you repeat the question again? I think I got it, but I just want to...
So, I'm talking about basically for any device to be ultimately successful is the full experience.
Right.
And device is certainly one part of it. But
right.
The other part of it is the app,
yes,
and the data and everything that you do with it.
Right, the entire, right.
So what is Intel doing to help developers on the back-end side of things to build an app, manage the data, and sort of build a full solution and bring that to market?
Yeah, there are a couple of projects, and we're still putting all the pieces in place. Of course, the hardware is our, it's our secret sauce, and that's what we aim for. But we are partnering with a couple of companies to, complete the stack. And since specifically these projects are open sourced, we provide everything so people can build their own services, and Intel, of course, is building their own services. So there is an array of solutions out there. I forget the name of this one project Intel launched a couple of weeks ago. It was a couple of months ago. It was really interesting. The idea is that once you have multiple of these devices, right? If you're a wearable company that you want to manage a fleet of Edisons, right? You basically connect all of these to the service, and you have a dashboard with all your devices, and you know exactly what they're doing and all that good stuff. So again, it depends on, the answer to your question will be yes, we have some of those solutions, but it's not limited to what Intel has. It's limited to what the ecosystem can build.
What's the cost of the board mass produced?
I don't have a number for a wholesale. I do have a number for each unit. At this point, it's sold for $49 on Amazon. $49 on Amazon. Yeah.
Well, that's cheap, right? It's expensive.
For the size, yes. Well, for the capability, I think it is. Yeah, it's basically a motherboard. Literally, a computer with these, with these capabilities 10 years ago. First of all, it looked like this. Right, the motherboard now is like this. So, yes, it could, depending where you're coming from, it could be expensive or cheap, but for rapid prototyping compared to the competition and the capabilities, we think it's a reasonable price.
Got it, because if I'm looking at, say, a wearable that is about $75,
or the board? I mean, if the board is going to cost $45.
Right. Again, this is not a wholesale price. So yeah.
For those who couldn't hear, the question was if the board costs $45 and if the product is the price point for the product is $75, it's too expensive. That's what he's trying to say. But Carlos says when it's mass manufactured, it can go down.
It's going to go lower.
Yeah,
I mean, I cannot give you a number, but
$5.
Don't quote me on that number, but yes, it's going to be cheaper.
The chip itself is probably the one that is going to be the first.
Yeah.
All right, we have one to the left.
So just a follow-up question to what somebody was asking, the entire ecosystem, right? So a lot of us kind of understand the software side of it. It's easy to go ahead and build something and get a prototype working. But the difficult part is once you have the prototype to go and talk to manufacturers, talk to the suppliers and figure out the entire process. So is Intel doing something? I do understand that there are a few companies like CDUino that do help with the entire process.
Right.
But is Intel doing something in this regard?
We are partnering up with people who know how to do this. I mean, we don't mass produce consumer electronics products. That's the reality, right? So, and I mean, Intel is adjusting their models for that specific market. So to answer your question, basically at this point in time, we don't have that. We don't, I mean, we supply the boards and the ecosystem, we support the ecosystem around it. But I don't know what the plans are to get to that point as of now. We're just partnering and, referencing to companies who actually do this type of stuff.
Okay, we have one question towards the back wall.
Hey, Carlos. How do I make sure that my whatever that wearable design can cover use cases? Like if I design a ring or if I design some watches, what is the maximum user interface can I provide in that? Any frameworks you suggest?
Sorry, I didn't get the question. Say that again.
Is there any framework I validate, like how do I validate my use cases using the wearable devices? If I design watch or ring or whatever it is. So what is the maximum use case I can go up to? Because there is n number of use cases I can cover with that, right?
So
including power and, like I'm asking in terms of power and performance.
Okay, let's see if I understand the question. So you're saying, how do you validate your use case from a power performance?
No, from any perspective, not necessarily power. So he wants to know, I mean, he wants to baseline to validate his, how much power is it consuming or, that kind of, do you have any kind of a baseline?
If you want a number, I personally do not have a number now. I do not. Now, how do you validate your use cases? Again, it depends on your product. What I would start doing is to validate the use case and focus on the users using the techniques that that we showed before. And to do that, to validate the use case, you really don't care much about, well, of course you do longer term once you've nailed the use case, but initially you don't really care about the technical specs. The technical specs come after you clearly identified that a use case, that use case has a value proposition in the market. So what we do in our lab is we put technology aside for a minute. We focus on the user, focus on the use case, work with our users, rapid prototype the concept. If there's a fit, then we start, we come up with the requirements and then work with the business unit to come up with a product that actually meets those. But as far as power consumption and an envelope at this point, personally, I don't have a number. Yep.
Okay. All right. Any other questions from anyone? Anyone here? All right. We got one to the left.
I'm sorry. So in the wearable space, a lot of times, one of the biggest questions is Bluetooth versus Wi-Fi. What makes sense? And the Bluetooth market has come a long way where people have developed Bluetooth low energy modules. Where do you see Wi-Fi going? Because most of the home automation things that most of us work on, they will typically either need Wi-Fi, but most of them are not. Power-wise, power consumption-wise, they are still not there yet as far as Bluetooth is concerned. So where do you see that market going?
Yeah, that's a good question. So that's the reason why this board actually has both, right? It has Bluetooth BLE and it also has Wi-Fi. You're right. as soon as you turn on Wi-Fi, you're going to drain the battery, which actually goes back to that question, because if you have use cases where you need Wi-Fi or Bluetooth on all the time, you're going to be, you're going to be draining the battery, right? But yeah, to answer your question, I personally do not know where Wi-Fi is going. Of course, in these type of applications, it does drain the battery, especially for wearable devices. The technology that we have for Wi-Fi, it just drains your battery, and that's why we have, low-power Bluetooth on this module. We think that, that is going to, at least at this point, it's the way to go. Maybe Wi-Fi, may change later, but at this point, we have both, just to make sure we cover both angles.
All right, folks, is there any more questions? Thank you so much, Carlos, for your time.
Thanks, everybody,
it was a really valuable
thank you.
information.